Homework 3, problem 9. If I have two charges of the like charge in this case, that are held together by a massless string, and I come and I cut the string, they're going to shoot away from each other. And the question is, how fast will each charge be traveling when they're very, very far away? The easiest way that I know to do this is to just do an energy balance, so we have to bring some of our mechanics skills back in. We're going to use conservation of energy, so we're going to use the electrostatic energy will get turned into all kinetic energy, and we're going to use conservation of momentum. There is zero momentum in this case, there needs to be zero total momentum in the final case. So the conservation of energy is going to state that the electrostatic energy, which is QA, QB, over 4 pi epsilon naught. Do I have a distance, how far apart they are? We just write down A. Okay, so we're saying that this distance here is A. This must be equal, after I've cut and they're moving very, very fast, ma, velocity of A squared, plus 1/2 mb, velocity of B squared. In addition, I have that the total momentum of the system must be 0. So ma va, let's say that this is the negative direction. So the direction that the A particle will be moving is positive, so that's the positive direction there. Minus mb vb, where here, since they're moving in a linear direction, the vector part can just be held by a minus sign. Plus means moving in the plus direction, minus means moving in the minus direction. Must be 0. So this is fairly easy. We just need to solve for VA and VB with these two equations. Substitution works just fine. I see that MBVB is equal to MAVA, and so I make a substitution up there. And so that will give us that QA, QB over 4 pi epsilon naught A should equal to 1/2 MA plus. In order to get MB squared, I had to multiply and divide by MB, so I'm going to get MA squared over MB VA squared. So solving for the velocity far away, VA is then the square root of QA QB over 2 pi A epsilon naught A MA plus MA squared over MB. And then by symmetry, all I have to do is swap all the A's and B's, and I get the velocity for B. So it's the square root of QA, QB over 2 pi epsilon naught A, MB plus MB squared over MA. That's it.